Hey everyone, I am Ayush. I'm working as a front-end engineer at Disney Hotstar. And today I'm going to talk about something different, a little different from what we are used to in our regular engineering workflows. I'm talking about the possibility of building a Codegen platform in a server-driven UI. So let's see, how can we make it happen? But first, let's understand what's the problem statement I'm talking about. So imagine a scenario where product designers would be able to just compose their designs and they will actually be automatically be converted into code. How good would that be, right? So that's the end goal, and let's see if we can tackle it and get our and carve our way towards it. So right, server driven UI has been really hot lately, and a lot of organizations have been adopting it, right? So it's obvious that in a fairly large organization you have a lot of product designers, have a lot of people in the engineering team as well, right? And they don't speak the same language because, of course, when you have a bigger teams, right, they are used to work in close silos. So is it possible to unify this language to an extent? Well, we'll get to it. But let me ask a question. Why should I actually be doing it? Is there any return of investment of doing this? Well, there is. So the biggest one being you will be able to save engineering hours because front-end engineers now would be able to focus their meaningful bandwidth on working on something else, working on building scalable components that could cater to different product tasks, right? And instead of regular workflow of composing the components which we're used to, right, we would be able to actually work on architecting them in a right way, in a scalable fashion. And of course, this will also reduce the chance of errors. There's a uh, famous quote cannot get out of my head. If a machine and human can do it, then a machine should be doing it. So that's the thing. If we can automate this to an extent, that would be really great. And also, often less talked about aspect about this. Well, it will also help us build some empathy with designers. We'll be able to empathize with product teams better, and designers would be able to empathize with us in a better way. And of course, you might ask, well, this is not something new. To an extent, this might already exist. Yes, there are certain automated plugins and pipelines for generating those Figma tokens into automated PRs. There is also a workflow for generating the color tokens, and all of this exists. But today, what I'm really interested about in talking is a possibility of composing the components and generating the code out of it. So let's see. And of course, as I mentioned, this already exists. Well, I also experimented with something 2 years back and I built a Figma plugin, right? And it enabled to spit out HTML and Tailwind code out of your auto layout designs. But the thing is, the uh, this plugin or any plugin in the market for that matter cannot speak the same language as your framework. Your framework for your organization is unique to you, right? And there has to be a custom solution that you might have to build ground up. So that's the thing. So let's do a quick recap. I don't expect everyone to know about server driven UI. There nothing to worry about. I will be just talking about the overall architecture of how server driven UI is different from conventional way. So a server driven UI, unlike conventional UI, you have the capability to change the layout from a server response on the fly. How cool is that? Because think about it, we are used to write and compose components and hard code those components, right? If you have to generate a page for google.com, how would you be doing it? Well, you might build a menu component, you might build buttons, you might add a search input, and you'll just be hard coding those components for, let's say, Google homepage. But well, so what server driven UI will enable you is to have these individual components and individual atoms in your framework. And you just send a JSON response. Hey, I just wanted to render maybe a menu component. I just want to render a container component. And you would be able to do it. So that's the paradigm shift, which is precisely server driven UI. And it, of course, makes everyone happy because It's you get rid of a conventional way of hard coding the UIs, right? So that's good. You are happy. You are able to ship things faster. So of course your manager would be happy about it. Personalization and A/B testing is also enabled, right? So product team is also happy because they don't have to wait for the deployment cycles. And let's, for the sake of this talk, let's build a small framework server driven UI. Let's talk about certain components that we might be able to build. And I'll prove to you that with those components, I would be able to generate any layout on the fly. So in React Native terms, well, these are the core components that React Native API provides. View, scroll view, you are able to use these as containers. You have presentational components like text, image, text input. But I want to make an argument that these are pretty much everything that you might need for building anything, any UI for that matter. So think about it, right? You have a server-driven UI framework where backend speaks the same language as these atoms that I just talked about. And from the backend, you are able to get a response, something like this, that, hey, if the component type is container, it might hold another bunch of components within it, right? And you might have an image component, you might have a text component, and a number of components that I just talked about. So with this tree structure, I would be able to render anything on the fly, right? And of course there might be some custom components, because of course for the semantic sake and for the sake of your use case, on the case to case basis, you might have, let's say, a card component, a button component. Maybe you might need a carousel component. So that's fine. I mean, these can still exist. And what's special about server driven UI is, well, these components, the server also understands the contract and the props that you might inject into these components. So that's how server-driven UI usually behaves. So that's good. We have established our server-driven UI for now. And let's look at some sample UIs, if at all it's feasible to build such UIs. Well, for instance, if I talk about google.com, you might build it like, you might have a container. Within this, you might have another container and a menu component, bunch of buttons, another menu component, another button. Then you might have an image component. Again, the parent container might actually have some layout styling for y-axis. You can change it on the fly because you might have something known as layout props. So by driving the layout props, you would be able to do that. And yes, so you might have some container components that are actually dealing the y-axis, right? And in the x-axis, right? So that's very well possible. So you can build, of course, google.com like this. How about Instagram? It looks fairly complex. Well, yes, you again, a container component, a parent container which might be in y-axis. Then you might have another container which is in x-axis with an image for Instagram logo. You might have some buttons on the right hand side, button components. You might have a custom button just for a story section. Of course, you can have something like that. For the sake of use case for Instagram, maybe they might have a card component. Within the card, they might have a carousel component. So that's specific to their use case. So I just wanted to prove to you, showing that you can build this UI on the fly using server-driven UI. In fact, that's how I believe Meta is also doing this. So yeah, we have established that server-driven UI is powerful. Let's look at the design part of things because we want to bridge that gap. So thankfully, actually, Figma provides a lot of capabilities to designers, and in a lot of ways, we are not so different because uh, designers also have this capability of something known as auto layout, which is pretty much like a flexbox system that we do have, right? So it's pretty much analogous. You have, if I show you this video, and yeah, designers also make use of this to lay out and position their elements. So there's a very well possibility you can transpile it to actual code. And of course, another powerful feature that Figma provides is the capability of generating components, which is pretty much what we do, right? We do have certain components. We are composing these components, right? And Uh, In fact, designers also compose these components just like us. So yeah, now that we have established that they might have some design tokens and we might have some components, let's bridge that gap. So thankfully, Figma also provides certain APIs for you to actually hook into a design and extract some meaningful information out of it. So of course there is, uh, we'll get to that. I'll show you in a minute with a live demo actually. That would be better. And let's have a look at certain designs. So I just talked about google.com, for example. If I look at it, and if I do something called as Figma dot current page dot selection, I get something known as a live node. This is a live with lot of getters, as you can see. I hope it's visible. I'll just make it a little bigger. And you see right on the hand side, this is what a designer sees. These are containers, the menu, the text. These are the components that I just talked about. These are the components that exist in our server driven UI framework as well, right? And if I look at the tree, right, the tree structure out of it, well, this is what I see. Uh, it has something known as type. This is, of course, what internally Figma uses. This is a Figma API. And it might also have different constructs. So for example, I'm just focused on a container component, right? So container might have another bunch of childrens, right? So in a way, it's a NRE tree that you might get out of it. And we have established our component names, right? If design and engineering component names speak the same language, then we should be able to transpile these designs into actual code. How cool would that be? So these are the name of the components. As I just showed you, this is container. Within this might have another bunch of children. This might have some layout properties like flexbox. So those can also be transpiled. Again, this container might be holding another container. There is an image. This container is, as I talked about this, let me show you this way. This is for google.com living in y-axis. And within this container, there is another container. This is probably for this x-axis containment. And this has two children, maybe another container, and within that you can actually find another container and image. This is for your image component. And just like that, you have the entire design as a NRE tree. So the idea is to generate this or transpile this component, this entire tree, into something that your framework understands, right? So yeah, that's about one of these designs. I can maybe show you another such design as well to make you believe that this is possible. And let's have a look at the selection. This is again a frame node, and this might have the same set of names and children. So we have established this, that these component names need to speak the same language. So if I show you a component name of uh, this component that I've just focused upon, this is again a container, right? So if we have a look at this from the left-hand menu, you can see I have established some of the uh, components that might live and that might exist for this specific use case for this organization, right? So this is a chart component. So again, this might be specific to this organization. They might have something known as chart component, for example, right? So that's about the Figma APIs that we have to our disposal, and it's really good. Now we just have to do is to transpile it to something that our server understands and our client understands. So let's see how can we do it. Well, what we can do is to take that live node, that container, that tree that I just showed you, and generate a model out of it. This model, which is actually contained to all the components that you might have in your system. And so, for instance, this model might have container node, text node, input node, image node. This is all that your code base understands, right? And what you can do, this is the intermediate node, by the way. This is nothing but what I just showed you, that we already had this intermediate node where all you have to do is to get rid of certain properties, because maybe I just don't care about constraints at all. I don't know what Figma constraint might be. So we can just simply rid of it and just have an intermediate node structure of this component. And going forward with this intermediate node, what you can do is to write a generator function. This generator would be responsible for transpiling this node into actual code and actual component. So let's see how we can do it. So suppose on the very right hand side, you can see we have some special handling for all the components that my system might understand. I might have container, image, text, menu, and n number of components. I just need to do special handling to transpile this into something that my backend layer understands, right? So let's look at a sample. Maybe let's look at how we can transpile our container node. So this is very important. On the line number 7, we see an instance of container node. This container node instance is uh, something which is a contract. A contract is something that you might have established from your server to your client, that hey, this is my understanding of props that I can deal with. And all you have to do is to take that node, that Figma node that I just talked about, and maybe it might have some children, right? So on line number 5, you just have to just run this recursive algorithm on those children again, and it might do the handling for the same types, all types of children, of course. On line number 7, as I have instantiated that container node, I can simply just pass those props that my container node understands. So maybe it just understands name and layout properties, right? It might only understand the properties of Flexbox. So I can very well do that. And of course, because this is a container node, it might hold any n number of children again. I can just simply pass in child nodes that I just transpiled. Those are again your uh, transpiled code that your server might understand. And if you do all of this, well, you would very well be able to generate automated PRs for something known as binder. A binder is your precisely a layer where in your server driven UI where your components live. So, and that's the end goal, of course, right? Because currently in most of the organizations, binder layer has to be done by manually by the front end engineers that are working at organization. So yeah, I think yes. I don't have the exact contract. Maybe we can discuss about it offline. So yeah, that's looking like a step in a right direction. And yeah, now what will essentially happen if you do all of this? You, when a client requests for a response, hey, I want to render a page. How should that look like? Well, you can just your binder layer would actually just spit out this JSON layout as a JSON, and you would be able to render that UI that I just talked about. So how cool is that? Well, uh, it goes without saying we should also acknowledge some of the shortcomings of the current system. Well, the first and biggest shortcoming is that if a designer makes some unauthorized edits to the components, so if I, for instance, just change the name of the component, right? So I have breached that contract, which I share with designer and my client. So that will break the system, right? Interactive components can also be tricky because, hey, I maybe would not be able to generate an animated component. I might not be able to transpile it into actual thing. So that's also tricky. And well, I also goes without saying, I should also acknowledge that l- this Codegen platform might be dumb in nature because action chaining, because you might want a button to do something, right? I have not defined that in my layer, right? So if I, even if I'm able to render button, that would do nothing, right? Unless I attach any action to it. So for now, Codegen platform cannot do that. And internationalization again is not handled because Of course, it may only transpile to the certain language that uh, your designer has provided your mocks in, right? So that has to be done manually. But yeah, I think it has definitely uh, reduced a lot of effort for front end engineers that they had to do for actually composing those components for the binder layer. So I think that's pretty much about it. We can take up I can take up questions offline. Thank you, everyone.